I would like to welcome you all to the session of Women Tech 2020 conference, and I am pleased to say that we have 4 distinct speakers, and to really utilize their expertise and see the presentations, and we'll try to keep time for any questions that might any other audiences might have. To go straight, I'll start with our first speaker. Mr. Simon is the managing director of the MobLab. He was the project manager and safety expert at the Swiss Federal Office of Civil Aviation. Actually, Mr. Simon has extensive international experience, having lived and worked in USA, Germany, Hong Kong, United Kingdom, and in the Kingdom of Bahrain. So he's really a well-placed expert and scholar. And I hope by the end of this conference, he will start adding Saudi Arabia and the Emirates to his trips. His speech is going to be on the transportation systems, asset management, and maintenance in volatile demand. Please, Mr. Simon, please start. You have 10 to 12 minutes for your presentation, so that we leave some time for questions and answers, which are very important for us. Yes, please.
Thank you, Mufid. Thank you, everybody, for inviting me to this first virtual conference. Unfortunately, not in presence. I will talk today about the asset management and maintenance in volatile demand, taking an example of what we are living at the moment in Europe and the world. Transportation system is under pressure, basically. And this is something that we can have worldwide. One small excursus on the presentation. Yes, 2 days ago, this train, and I send you my warmest regards from Switzerland, and you can see the weather here is pretty cold at the moment. This train made the first operation through the Alps. It's a new connection between the main center, Zurich and Basel, and the south of Switzerland. And at the same time, the Ceneri Basis Tunnel, which is a 15-kilometer tunnel, open on Sunday, which makes the distance between Milano and Zurich or Germany or even Netherlands a flat road. Before we had to go up to the mountains up to 1,200 meters, and now you basically have a flat road, which is very good for cargo and very good for passenger, which reduce drastically the times. Transport system in general, we have a demand. Somebody wants to travel. The operator makes an offer. We adapt our assets if necessary, and we go into operation. Pretty simple. However, 3 examples. The first one is aviation, then bus operation, and then railway. The system are differently certified. Aviation is international regulated. Buses are national, and railways is a mix between the two, because you have trains traveling from one nation to another one. This shows as well the lifespan that we have basically on the different vehicles. Can be 10-15 years, or 1.5 million kilometers for a bus, more or less, or 40 years. At the moment, we have one big thing. We have 4.5 million. Excuse me 1 second. Small problem. We have 4.5 million for a locomotive, 25 million for a train composition. On the other side, we have 250,000 million for an aircraft, and you see the difference on your asset. Why we do maintenance? Basically, in general context, to maintain operational stability, to protect the asset, to protect the company on the safety side. At the same time, we have to minimize the risk in a volatile demand, or we have to protect the asset and reduce cost on the operation side if we have a drop demand, to protect the company as well on the safety side. The Swiss public transportation, we can go almost anywhere from anywhere in almost every time in one click. All schedules are coordinated. It doesn't matter if you travel by bus, by boat, by tram, or by train. Aviation is not considered part of the public transportation. The cooperation, feeder, and reciprocal importance of both systems, however, are widely recognized. Here is an example. If I travel from a small village, which is Waldkirch, up on the right corner, through St. Gallen, Argoldau, Bellinzona, Göschen, and Andermatt, and Discours, and back to St. Gallen, I use 7 different providers, which are listed on the right-hand side. Bus operator, Postauto, Turbo, SOB, SBB, Tilo, which is a normal gauge railways, and Mater Gotterbahn, Rätische Bahn, which is narrow gauge railways, and again SBB. And this basically in one single click, I get my way to travel. One ticket, best price, fully coordinated. And as you can see, all timetable or times are, you have about 4 or 5 minutes to 14 minutes time, transit time, every time that you use. And this can be in anywhere in Switzerland. Going back to the transportation system, government request the public transportation, and you have a market demand. Then you do your service and your scheduling. You adapt your fleet, or you invest on your fleet, and you basically operate. The difference between public transportation and aviation is pretty simple. You don't have any government request. The market is fully privatized. You have international agreement, and you have entry requirement, which is now one of the biggest problems in aviation. If I see the baseline on the demand of 2018 compared to 2019, we have an augmentation of 1.8% for aviation and 5.6% in the public transportation system in Switzerland. And this is basically the number of passenger development from 1950 to 2018 in Switzerland. As you can see, you have a drop in 2001, which is due to the bankruptcy of the National Airline, collapsed in October 2001. And the drop basically lasted for a couple of years. Then it picked up again, and we had the financial crisis in 2008. We have a slight drop and then a continuous increase to last year, or let's say 2 years ago, to 58 million. What is the situation now? We are back to 17 millions, which means we are back 33 years. On 1987, we had more or less the same amount of passengers. Here you can see what kind of volatile demand, what I mean with volatile demand. We are used on the last 2 years, in the last 8 quarters, not comparing it to 2020, we are used to basically have about 40 million passengers in average. And suddenly we had 317,000, a drop of nearly 98%, which is something dramatic. The average for 2020 is about to be 2.4 millions compared to 14 millions average for the last years per quarter. On the right side, the drop was less drastical, basically, but the IMR very always very important. Almost 65% in Q2, and the estimate we are not able to tell exactly at the moment, but is about 30 to 45%. One another things in the last months there is a significant augmentation of the drop, so all the forecasts will be probably much worse than that what I publish here at the moment. So that's the situation that we are talking about. A drop of nearly 100% for aviation, and maybe if we are lucky at 70% at the end of the year, and a drop of about 50% in the demand of public transportation. As you can see, basically you have 80%. I mentioned 80% for the drop, and not 65, because as well the bus and lighter railways were not included in the graphic before. The cross-industry impact, we have basically aviation and public transportation system is basically linked to an immense number of businesses, which can be food and beverage, cleaning services, airport services, air traffic control or rail traffic control. All these services beside the operator will be hardly hit from this crisis. Normal process from adapted from one of my distinguished colleague, Professor Claudio Ronaldi from SUPSI, is basically you analyzes your demand. If there is no asset solution, okay, you solve the situation in other way. If you have an asset solution, you have to increase or upgrade. You define your need. You analyze the manufacturer that you have at your disposal. And at the same time, you draft your concept, you validate, you do a tender. Once the tender is done and you select it, you go in detailed specification, interior design, livery, all the soft factor. And then you have to adapt all the operational and management elements that you can see on the right-hand side. I will go back quickly later on. Just to make a sound information about the cost of transportation in Switzerland.
Mr. Simon,
yes?
Sorry, you have about 2-3 minutes.
Perfect.
Yes,
perfect.
Thank you. Yeah.
We have about 14 billions for public transportation and 7 billions for aviation. And due to the fact that it is subsidized, the public transportation, 50% is covered by the state and the rest is covered by the users. On the other side, aviation, you have almost no subsidy, 1.3%. And a simple example, airline, 100 aircrafts, 200 aircraft per fleet, seat load factor 87%. You have on average taken 87,000 seats with a drop of nearly 89%. You have basically 2,150 seats taken. 50% of the aircraft is owned, so is your capital. In this case, quick reaction, sale and lease back, if you can, rebook on the license, early return in the leasing, new concept on supply chain or renegotiate lease. On the public transportation, you have basically urban and regional are subsidized, and the long distance self-supporting. As I mentioned, the real big drop. You have the only thing that you can do is reduce operation. I'll go back to this. What we can do, basically, when we need to do something with our assets. On the side, to protect the liquidity, you have a sale possibility because you don't use it, or a sale and lease back. Your long-term storage for return to lesson. the crisis is expected to return only in years. Asset upgrade, short-term parking, is you expect to return soon. You can basically use the ground time to upgrade your fleet, or you basically use it as an ops reserve or scheduled maintenance if you can. But at the moment, we don't know. Actually, we really don't know what we can do because the crisis doesn't allow us to make plans. On the operational side, you have to operate in EBIT neutral operation. That means that if you do an operation, it has to be EBIT 0. Otherwise, you will start increasing your loss. Supply chain, you have to concentrate locally or selective, reduce your inventory, and so on. Data management, use different scenario and help with artificial intelligence. Employee, there is a crossover demand. Some pilot, for example, in Switzerland can now go and use trains or be trained as a train driver for only limited of time. And another last things basically is the synergy on the spare side. If you have a spare on a normal level, you have a reduced operation, you adapt your levels and you adapt your reutilization if you need to use the aircraft which is parked, for example, and take some components from there, because on the other side, you don't have the same normal transportation availability because nobody flies. And when you operate with a fly, you have basically to work flexible, flight kit, engineering on board, or help yourself with other means of transportation. Basically, this situation in transportation is pretty dramatic at the moment. And if there is no recovery within few days, few months, excuse me, we will see a lot of possibly a lot of company going bankruptcy. Basically, act immediately, reduce your exposure in the invested capital as soon as possible if you have the possibility. Cooperate with your partner or former competitor to survive. Give in some concession or reinvent your services, and really concentrate on the feasible in this situation. And lesson learned: next time, be prepared. Don't expect a continuous growth all the time, but be prepared to something. Maybe not in this size, but be prepared.
Okay.
Thank you very much.
Okay, thank you, Simon. That was really very enriching, and we have a few questions, but I don't think we have time. Maybe at the end of the session, just one question, if I may, Mr. Engineer Naimi. Could this concept benefit from utilizing a statistical analysis software?
As I mentioned, on the IT side, you have to build up scenarios, and the best way, I think, to simulate the future will be using artificial intelligence. Statistical used to basically get your baseline and see what was, how do you say, in the last few years. The problem is that we have a situation that we never experienced. 98% drop is something that is a nightmare for everybody, and you have really to think out of the box at the moment.
But is it feasible to include all asset management aspects in one model?
You can basically use different scenarios for different assets, but in mobility you can make several comparison and basically learn from one of another industry. I came from aviation, now I'm working in mobility since 6 years, and basically what I learned, there is not a huge difference between the industry. So look one other reasons how they do it and try to get the best out of it.
Right. Okay. Thank you, Jan. Well, that's very clear. If we have time, we'll answer the rest of the questions or
Yes.
I'm sorry we cut down your presentation a little bit, but it will be available for all the participants. May I ask now, thank you very much. May I ask now Professor Andrew kindly to yes, join us.
Well,
okay.
I'm here. I don't have my screen yet.
Yeah, we can. I think we can see you all. Yes. Okay. Let's have your first slide of your presentation, if you please.
Gaowei, would you share yours, please? I can't get mine up.
Okay. So okay, I'm sharing my screen.
First of all, I would like to welcome you, Professor Andrew. I mean, you have a very impressive bio. Professor Andrew is the founding director of the Center for Maintenance Optimization and Reliability Engineering at the University of Toronto. He is also, of course, Professor Emeritus in the Department of Mechanical and Industrial Engineering at the same university. I looked into some of his publication and books which he has published. It's amazing. I am sure you are a stand-alone person and to follow up your work and with the Professor Andrew. He will be joined with Mr. Gaowei, who is a Ph.D. student who specializes in optimization, machine learning, life cycle engineering, and road design. So please, Professor Andrew, you have 12 minutes from now. Thank you for both of you.
Thank you, Professor Mufid, for these kind words about my background. I'm honored to have been invited, along with Gaowei and his supervisor, Faye, to present at this conference. And if we go to our next slide, what I have here is that the conference is all about roads, and this theme today is roads and transportation system maintenance. And within that topic, our brief presentation today is going to focus on the role of evidence-based asset management in infrastructure asset management. In particular, the presentation is going to demonstrate how mathematical modeling, in particular, the statistical procedure of proportional hazards modeling, PHM, can be brought to bear to extract valuable information from bridge inspection records to enable optimal maintenance tactics to be identified. So this work is done by Gaowei under the supervision of Professor Samarai. We mentioned the word PHM, proportional hazard modeling. There have been many applications of this dealing with physical asset management, pumps, gearboxes, diesel engines, and so on. Very few applications of PHM regarding infrastructure asset management. So I'm going to hand over to Gaowei now to speak about the application of PHM dealing with critical components in a fleet of bridges in New York State. Gaowei, over to you.
Okay. Thank you, Dr. Jardine. Hello, everyone. Good morning. Okay. So before introducing our approach, let me review the current bridge management approach. Well, bridge maintenance management is a trade-off between bridge safety and maintenance costs. As we know, all structures are deteriorating. Well, if a bridge is not well maintained, its condition may get worse and becomes unacceptable and even collapse. Look at this picture. It's a bridge collapse in the US in 2007. Well, obviously, bridge collapse results in a big loss. Not only bridge reconstruction costs, but also indirect costs like traffic detour, construction, material garbage, and even life loss. However, spending too much money to guarantee an excellent bridge condition is not cost effective. Well, in a state like New York, there might be over 10,000 bridges. Maintaining these bridges is a super heavy financial burden for the government. Okay, this survey shows the current condition of infrastructure in the US. As you can see, the overall condition is disappointing. Well, bridges have a slightly higher degree C+, owing to mandated routine inspections and bridge management system. However, the deterioration model in the current bridge management system have unrealistic assumptions, and they fail to exploit the information provided by inspection data as more as possible. So there's still something we can improve. Well, people usually underestimate the benefit of preventive maintenance of the infrastructure. A previous study indicated that each dollar spent on the improvement of highway system can return $5.2 due to lower decreased delays, less fuel consumption, and improved safety. Okay, so such a topic is very meaningful. So on this slide, let me show you some background knowledge about the National Bridge Inventory Database. Well, this is a very huge database. It contains routine inspection data for all the bridges in the US since 1992. The most important index in the NBI data is condition rating, describing the structural condition. For each bridge component, its condition rating is classified in this way, 0 to 9. A higher condition rating means better structural condition. Well, here we have two pictures. The upper one is a concrete bridge in excellent condition. You'll see the concrete is sound and the structure is nice looking. However, the lower one is a concrete bridge in critical condition. You will see that there are many wide cracks on girders, and there are some spalling concrete on the ground. Well, without maintenance, structures deteriorate naturally, so condition rating might drop year by year if no maintenance. Okay, so like this bridge, its deck, superstructure, substructure, all its components, their condition ratings drops gradually over time, like this. Well, we can use the deterioration model to describe the condition rating drops. However, the current bridge management system use condition ratings only. Well, they don't consider age effect. What is age effect? Well, as we know, like a machine or human beings, older bridges get worse faster than new bridges. Well, actually, fortunately for the age effect on bridge deterioration, we can actually find it from the MBI data. Well, in our approach, we create compound state to describe the state of a bridge in its lifetime. Okay, there are two classifications. For in-service bridge components, we use the 3 variables together to define its state: inspection number, condition rating, and age at the beginning of planning horizon. Also, we have a failure state. Well, failure state means the structural condition is unacceptable. It's not necessarily to be like bridge collapse. Any unrepairable status can be regarded as a failure. Here, we define condition rating less than 3 as a failure state. For this state, we just use F to denote. So let me give you a small example of how we label compound states for a 20-year-old bridge in a given planning horizon. Well, at the beginning, we have the first inspection. It tells us the structural condition is 7. It's a 20-year-old bridge, so this compound state is 1, 7, 20. Pretty simple. So after 2 years, we're going to have the second inspection. It tells us the condition rating is still 7. So we have 2, 7, 20. And more inspection, we got a series of compound states for this bridge. Well, let me show you how we incorporate the PHM here, proportional hazard model. As you know, compound states are just like labels. But what people really want to know is the likelihood of a structure failure. In other words, the structural hazard. So we should find a way to combine the 3 parameters in the in compound states together to represent structural hazard. In our study, we use a proportional hazard model with Weibull baseline hazard called WPHM to calculate the structural hazard. Well, you can see this is equation, the formula. T is time. It's equal to inspection interval times the number of inspection. So which measure the time effect. That's good. Well, you can also see the condition rating and age, initiation age, are included in the exponential part. And beta is a shape parameter, eta is a scale parameter, and gamma are weights of the covariates. So this is an example of the WPHM of a bridge decks in New York State. We can easily obtain this model parameters using maximum likelihood expansion. Okay. Let me give you an example. This is a WPHM of okay. Oh, okay. So we determine the maintenance policy based on the hazard of a bridge deck, right? So for bridge decks, we have 2 types of preventive repairs: general repair and essential repair. Well, the major differences between the 2 repairs is essential repair results in higher bridge quality improvement, but it costs much more than general repair. For example, to concrete bridge decks, general repair can be using crack sealer to seal the concrete cracks, because sealing these cracks can prevent water and air penetrating into the concrete, which leads to corrosion. Well, essential repairs can be patching decks using new concrete. To find the optimal solution in this study, I use Markov decision process to get the 2 hazard thresholds.
Sorry, you have about 2 minutes. We have a lot of questions for you.
Okay.
Just wrapped up. The presentation will be available for all, and
yeah, no problem. I just have
because you are jumping from slide, it's difficult to follow you. Okay, thank you.
Okay. Let's go on. So finally, I'm gonna share a case study. So for this bridge, well, this is basic information of this bridge, and our task is to find the optimal maintenance policy for the bridge deck in the next 30 years. Well, this is our final result. The top plot is prepared for a sequence of simulated inspection results. The planning horizon is 30 years. While the y-axis is the hazard value of the deck. In the top plot, there are 2 thresholds. The lower one is for general repair, the upper one is for essential repair.
Yeah.
Okay, so after each inspection, bridge managers get the hazard of the bridge, represented by a green dot, and repeat the same procedure at each inspection, and they can get a series of hazard value. Okay, so they make decisions based on the hazard value. If it's over a threshold, they're gonna perform their corresponding repair. Okay, so from this simulation results, Okay, so they're gonna perform like 2 general repairs, right? Okay, and the bottom plot is the corresponding expected annual maintenance cost. Well, the benefit of using this kind of contractor is you can observe the time effect. Like from 2022 to 2038, the condition rating remains at 6. However, its hazard value goes up 0. Also, the control limit is time dependent instead of possible in the current management system. Okay, so the last this is the last slide. So I will tell you how to expand our model from one bridge to a bridge fleet. So in using our method for each bridge, we can obtain the maintenance cost for each component, bridge deck, superstructure, and substructure, while using different WPH model. Okay, so we will get the cost for one bridge, and repeat the same procedure for all similar bridges in a bridge fleet, and finally summarize the maintenance cost for all kinds of bridges in a bridge fleet, and we'll get the total budget for this bridge fleet. Okay, so basically it's a bottom-top approach. So here are some references, and thank you very much. Any questions or comments?
Thank you. I think we have some questions. Let me see if I can see them here. Oh, can you this? تقريبا ليش بتطلع questions ليش بتطلع؟ Anyway, okay, so, we have a question, Mr. Rani Kawash. What is the source of the infrastructure report? Report card and showing condition of the infrastructure elements in USA. Can you hear me?
Yes, I can hear you. Okay. So actually, in the US, I think it's the Highways Administration is called FHWA. They publish a document, and the title is just the infrastructure report card every 4 years. And the latest version was in 2017, I guess. So the next one will be available in 2021. So it's published, and you can download from just Google it, infrastructure report card in the US, and you will see the WHO report. Yeah.
Okay. One more question, if you could answer it very quickly. We have a question from Mr. Al-Sudi. How can this methodology benefit from non-destructive testing methods for data collection?
Okay, it's a very good question. Well, actually, the data is collected from routine inspections. Well, these routine inspections they're basically non-destructive testing method actually.
Okay, thank you. I just forgot to mention, I apologize, that the third partner in the paper is Mr. Faye Azari. So there's he's co-author in the paper. Thank you very much. I think we need to move fast to Dr. Moustafa. So please, can we have his presentation on the page? Mr. Moustafa is a Moustafa Kassab has a Ph.D. in civil engineering and system design engineering from the University of Waterloo. He is also a faculty member of the University of Waterloo and Taiba University. Of course, he has numerous publications in journals and conferences, and he is a member of many well-established, well-known organizations like the International Association, such as American Society of Civil Engineers. We are co-members there, and IEEE and Transportation of Canada. So he's well placed for the presentation. So please, Professor Moustafa, may you let us have your presentation. And again, unfortunately, you are the last speaker, so you have to stick to the time window. Thank you.
Okay, thank you, Dr. Mufid. Is my screen on now?
Yes, please. No, you have not shared it. Yes. No, yeah. Okay.
It's shared?
Okay. Okay, yes. Now it's okay.
Okay, thank you, Professor Mufid. Also, I would like to thank the organization committee of the Omantic for their effort to conduct this virtual conference despite the circumstances. Also, I would like to thank the audience for attending our session. Today, I'm going to talk about the decision support system for infrastructure maintenance project using combined graph theory and house of quality approach. Okay. In my presentation, I will talk about the challenges facing the infrastructure and what
Yes, it's there. Please go ahead. I think we lost the presentation of Moustafa. I think he's refreshing his entrance to the site. There was another question, so in the meantime, let's to Mr. Professor Andrew. Could you please give examples of preventive maintenance for roads and transportation industry? That's from Mr. Mus'ab Al-Anzi.
Okay, so I just got the question here. Okay, so some example of preventive maintenance for roads and transportation industry, right? Is this a question? Hello? Oh, okay. I guess is this one because I remember you're mentioning roads and transportation. Anyway, okay. So yes, our study focused on bridges. Well, yes, our study focused on bridges. So we actually we also investigated some, and we do plan to investigate the maintenance optimization for roads. But that will be maybe the the project after I finished my PhD. Yeah, I'm also very interested in that part. Yes. For the road, well, nowadays most of the roads are asphalt roads, right? And for asphalt roads, what I've heard that there are many types of maintenance ways, like sealing cracks using hot asphalt, right? And overlay. And it's for overlay, they have different thickness, like 2 centimeter, 5 centimeter, or the entire overlay of pavement. Yeah, that's what I've heard. And yeah, because roads are like cakes. There are several layers, and for different layer, they have different treatments. That's a pretty interesting research topic. And I lost the question. Yeah, for roads and transportation. Yes. So does that do I answer this question? Hello.
You answered it very well. I think there are some more questions. We were still waiting for Dr. Moustafa to start. Simon, Mr. Sakan, can you hear me? Mr. Simon, can you hear me? No? Well, yeah, no. Can you hear me, Mr. Simon? I think he's not being able to start. Okay. We still have 2 or 3 minutes. I think I'll. Can I ask another question to Professor Andrew or yourself? How can the deterioration model be translated into a tangible maintenance schemes for the engineering and specialists?
Okay, so it's a very good question. We
Well,
actually,
I hope so. And otherwise they will not ask. Anyway, okay, yes, please. Yeah.
okay,
You have just 2 minutes. We have to wrap up this. Yeah.
okay, fine. So it's a very good question. Actually, we are the purpose of my research is actually I want to develop like a software or whatever which can help bridge managers or in the future road transportation system managers to maintain the bridge fleet. Actually, we will develop the methodology. Okay, so the bridge managers, they don't need to do coding work because it's pretty mathematical. We're actually using the pH model. Previously, Professor Jardine has developed some softwares like Exact for the optimizing the maintenance management for some kind of machines, right? And he has many successful applications in different terms of machines, right? Okay. And yes, in the future, I hope that I can also develop such a very useful software for infrastructure management. Yeah.
Okay. I think that as well as we have. I think we still have problem contacting to Sir Simon. I don't know, Mr. Simon, can you hear me? I think not. He's refreshing. Yeah. Let's. I have a question also. Can really this method be applied on bigger scale case studies?
Okay, I got it. So for a bigger scale study, it's like okay. So my understanding is like my current research is just develop. It's just developed for the maintenance management for New York State, right? So you're asking if it's possible to do for like the entire US, right? Okay.
Yeah, yes.
Yes, that's impossible. That's possible. Sorry, okay, that's possible. Because it depends on the management way of a country. As far as I know, in most of the countries, each state are responsible for their own like bridge fleet. Like New York, the bridge management managers in New York State, they're only responsible for the bridge and roads in New York State. They don't care about other states. So okay, so do you remember in my last slides? Well, actually, I did share my screen. Okay, anyway, so if you still remember my bottom-up approach, so we use a big WPH model to get the maintenance cost for each bridge and similar bridges, and then the entire bridge fleet of New York State, right? So finally, we will get the total cost of the bridge fleet in New York. That's the maintenance cost. Also, other states can do the similar things, like Washington D.C., right, and California and Florida, right? They can do the same thing and get the budgets of their bridge fleet, right? Okay, so and you sum them up, that will be the total number would be the total budget of the bridge fleet in the U.S. Right.
Yeah. Okay. Thank you. I don't know, Mr. Simon. Can you hear me now? Back. Okay. Okay. All right. Okay. We have some questions for you. I don't know if I can get back to it. Does the proposed concept consider best or worst case scenarios?
Actually, that's a tricky question. I always try to consider worst case scenario in any proposal at the moment, but we experience basically with the pandemic that in transportation, the worst case scenario at the moment is unknown. You can plan for anything worse, and maybe in 2 weeks is worse. And basically, the model that I propose take in account all the scenario that you want to put in, the scenario you have to develop yourself. And the worst case scenario is something at the moment is a question mark. Unfortunately, it's a really tricky situation.
Okay. Okay. That's really. I have a question. I just thought about what kind of data is targeted when analyzing social and ethical scenarios.
But the social data that we can see or we can access is all the statistical data that the Federal Office of Statistics and the Federal Office of Transportation put together, which basically are information about the behavior of the mobility system and the behavior of the mobility of the person who travels. On the ethical side, I don't know how to answer that, because what basically is what do you do or if I understand correctly, what you do with some information and how you can basically grant anonymity, or that you cannot see who is the person who has this data. Basically, all the data are anonymized, and you don't know who is traveling or where he lives. And this is basically what can I say on that. But otherwise, on ethical, I cannot give a detailed answer. Sorry.
Okay, that's the proposed consequence. Yes, I think, and if I can go back just 1 second. Because it was some time, no.
Dr. Mufid?
Yes? Ah, you are back?
Yes. What happened?
I don't know, we lost you, but I'm sorry, we have just 2 or 3 minutes. Can you put on at least the first slide and last slide? Can you?
Okay.
Yes, please. And for the rest of the speakers, yes, Dr. we have quite a few questions. I'll ask the organizers to send them to you, and you can answer them in your spare time. Thank you very much. Can you put your introduction slide and your conclusion, because we have only 2 or 3 minutes. We cannot take any more time.
Okay, I will go through the presentation first.
Yeah, well, it presents only 1 slide or 2 slides only. I'm sorry. We can't.
Okay, now can you see the presentation?
No, yeah, yes.
Okay, so in this, if you go back, I'm just talking about the decision support system. So like here is the decision support system. It consists of 3 elements, which has to be collected from the beginning. It's past experience about the contractor and survey collected, and senior management. Also, we have another icon, which is customer requirement, which is voice of customer. In this case, is the municipality, what they required for the project, and the technical ability criteria, which is the contractor ability to take the maintenance project. All this information will be utilized by the computer, the decision support system. That system will utilize all the information we collect from the database, and we can combine it with the graph theory and decision tree, and also we'll utilize house of quality approach, and based on this we'll get the optimum decision for the maintenance project. Here, this is case study in which I try to put a small project, and all these are the requirement by the municipality for the project. These are the contractor ability, and the system starts by drawing using the graph theory. We draw the project criteria, and here I put the project and their weights, the importance of their weights. Here, the interrelation between the weights of the criteria, and here I put the contractor ability weights, and it's important. Here we calculate what we call it the pre-qualification scores. Using all these mathematical information will be embedded in the system, so the user don't see all these mathematical equations. And
Okay.
we proceed to calculate we call it contractor pre-qualification index. We use a formula, and based on that formula, I listed here the contractor, 6 of contractor, calculating the index, and I rank the contractors. So based on this, I can find that this contractor number 6 should be ranked first, while contractor number 1 was ranked for number 6. So this is.
Can you? Sorry, Dr. Moustafa, they're going to close on. Yeah, just this, because they are closing
Okay.
up.
So in conclusion, I talk about the infrastructure aging and the challenge facing